In this video, we will discuss about chapter 4 on hydrogen for the second part. In this part, we will cover some discussion on hydrogen reaction, hydrogen compound, and hydrogen application. We will discuss on 4 reactions of hydrogen. The first reaction is reaction with oxygen. So reaction of hydrogen with oxygen will produce water and releasing a lot of heat. So it is typically used for hydrogen welding and metal cutting process. So let's say we have hydrogen gas and reaction with oxygen will produce water. So this one, the enthalpy is around 572 kilojoule. So the amount of heat that been produced is suitable for welding application. So this equation is not complete. 2 hydrogen, 2 mole of hydrogen reacted with 1 mole of oxygen will produce 2 mole of water. So this is an example of oxy-hydrogen metal cutting process in which the heat that been generated from the reaction is capable to cut a metal. The second reaction is reaction with halogen. So the reaction will produce halogen hydride. So let's say we have hydrogen reacted with halogen, it will produce halogen hydride. So let's take the real halogen for a quick example. So let's say we have hydrogen plus chlorine gas, it will produce HCl. Okay, the third reaction is reaction with metal oxides. So reaction of hydrogen with metal oxide will reduce the metal oxidation number. So for example, hydrogen in reaction with manganese oxide, it will produce MnO plus water. So if you can see here, the oxidation number of Mn here is plus 4. And after the reaction with hydrogen, the oxidation number of Mn became positive 2. So the reaction already reduced the oxidation number from positive 4 to positive 2. Another reaction, another example is reaction of hydrogen with lead oxide. So this reaction will produce lead and water. So if we can see here, the oxidation number of lead here is plus 2 and is already reduced to 0 after reaction with oxygen. So the fourth reaction is reaction with electropositive metals. So the electropositive metal is located on the left side of periodic table. So the reaction will produce metal hydride. So let's say here the example we have lithium with the reaction with hydrogen, it will form lithium hydride, so the metal hydride. So here we have 2 and 2. One of the hydrogen compound is hydride. It is a compound that contains hydrogen and one other element. So there are 3 types of hydrides, which are ionic hydrides, covalent hydrides, and metallic hydrides. For the first hydride compound, which is ionic hydride, it can be formed via the reaction of a group 1 or group 2 metals except for beryllium and magnesium with hydrogen gas at 400 degrees C. So the reaction will produce white crystalline compound with the oxidation state of hydrogen is -1. So let's say we have example of lithium in group 1 reaction with hydrogen gas, it will produce lithium hydrate. Two mole of lithium, 1 mole of hydrogen gas, and produce 2 mole of lithium hydrate. So the second example in group 2, barium in reaction with hydrogen gas, it will produce barium hydrate. So the ionic hydride undergo reaction with water to produce hydrogen. So we use the same hydrate compound here, lithium hydrate, in reaction with water, it will produce hydrogen gas and lithium hydrate. So for the second example, we have barium hydride in reaction with water. It will produce hydrogen gas and barium hydride with 2 mole of water. So the second hydride compound is covalent hydride. So it can be formed via the reaction with group 14, 15, 16, 17 and boron. So the acidity increased from group 14 to 17. Boron is from group 13, but the anomaly of boron can form a covalent hydride with hydrogen. So for group 14, for example here, group 14, let's say we use carbon. So reaction of carbon with hydrogen, it can form alkane, and alkyne. So the hydrocarbon. So for example, C2H6, C2H4 and so on. So for group 15, let's say we take nitrogen as an example. So it can form ammonia. So ammonia is a basic compound. Example for group 16, oxygen. So reaction with hydrogen, it can form water, for example. So water is neutral. And reaction with group 17, for example, reaction with chlorine gas, it can form a hydrochloric acid, HCl. So this one is acidic. The third hydride compound is metallic hydrides. So the compound containing a transition metals or sometimes other type of metals and hydrogen. So the hydrogen atoms spread throughout a metal crystal occupying the hole in the crystal lattice. The hydrogen atoms enter the holes in non-stoichiometric amount. So therefore, a composition of metallic hydride is variable. So for example, MH 0.4. So other example that can be metallic hydride is titanium hydride. For example, titanium hydride 1.76. Then we have tantalum hydride 0.6, for example, or palladium hydride 0.6. So the quantity of hydrogen is non-stoichiometric. Water is one of hydrogen compound. Water is among the most important compound in daily life. It exists in three forms: solid, liquid, and gas. It exists a solid form at temperature of 0 degrees C, in liquid form within the range of 0 to 100, and exists as gas at temperature of 100 degrees C. It is capable to form hydrogen bond among the molecule. So in water, we will have hydrogen bonded to oxygen and another hydrogen. That's why we have H2O. So here we have oxygen with 2 lone pair electrons. So because of the lone pair electron capable to have a repulsive force to the OH bonding, so it will bend and forming a bond angle of 104.5 degree. So the formation of hydrogen bonding with the molecules. So let's say we have water molecule, the first water molecule, and we have the second water molecule. So the formation of bonding took place between the first hydrogen atom from one compound to the next oxygen atom from the second compound. So this is a strong bond and make water exist as liquid at room temperature. Hydrogen is used for margarine synthesis. It is involving the hydrogenation reaction, which is the catalytic reaction of olefin in which oil with hydrogen gas in the presence of catalysts, for example nickel, to produce margarine. So we have palm oil in our country. So the process of hydrogenation will produce margarine from oil to from liquid to solid. So palm oil to margarine. So what happens is that the polyunsaturated fat that contained in oil will undergo the hydrogenation reaction. So the double bond will be substitute, or the double bond will be added with hydrogen to form the saturated fat. So here it is in liquid form, this one in solid form. The second application for hydrogen is hydrogen powered vehicle. So the technology called proton exchange membrane fuel cell, or PEMFC. So if you can see from this one is the prototype of car that using hydrogen as a liquid fuel. So if you remember the reaction of hydrogen with oxygen, so the oxygen is from the environment, it will only produce water as the byproduct. So in this case, it is more environmentally friendly compared to the current petrol-based vehicle. So in this case, what happens is that the hydrogen will produce electricity using the technology of proton exchange membrane fuel cell, and it will be used, the energy or the electricity will be used to rotate the motor. So the only problem or obstacle on this technology is that the hydrogen as gas is converted into liquid at a suitable temperature and pressure, and it will be stored at the car itself. So that's another application of hydrogen. So with that, thank you.